Viewers, let us construct a pair of tangents from an external point to a circle. So, this is the one of the important concepts, you may expect it for long answer, that is for 8 marks. So, here for the construction I am showing the things which are required: scale and pencil and compass, most probably the sharpener and eraser are the things. So, here majorly we have to use these 3 instruments. So, this is the instrument, call it as compass, which is used to construct, draw the circle, right. So, here the problem which is mentioned: draw a circle of radius 3 centimeters and construct a pair of tangents from 8 centimeters away from the center. Okay. So, here you need to identify the 2 things. One is radius of the circle and the position of the point. Okay. So, here the radius is given as a 3 centimeters, right. So, we have to consider the radius as a 3 centimeters. Observe this, this is the radius I am considering 3 centimeters. So, consider 3 centimeters as a radius and we need to draw one circle. So, here I will consider one point and I take this point as center of the circle and I will try to draw the circle. Okay. So, this is the circle of radius 3 centimeters. Okay. So, this is the circle with a radius 3 centimeters, consider its center as a O. Okay, students. Now, we have to plot the point, the external point which is at a distance of 8 centimeters away from center. Okay. So, from the center O you have to plot a point, you have to mark a point which is at a distance of 8 centimeters away. Okay. So, this is the external point, let us consider it as a P. Now, we have to join O and P. Okay, students. So, this is the external point P, right. So, we have to draw a pair of tangents from this external point to this circle. It is the given circle. To this circle we have to draw pair of tangents. So, generally what you think, most of the students try to draw the tangents like this. Simply they will try to draw the tangents from this external point to circle, but it is wrong. Okay. So, here we have to follow few steps. First of all, we have to draw the perpendicular bisector of this, perpendicular bisector of this line segment. So, you might have practiced how to draw the perpendicular bisector. Okay. So, which passes through the midpoint and it is perpendicular to the given line segment, that is nothing but OP. So, here I am considering the radius as a more than half. Observe this, this is the radius which is more than half. Okay. So, with this radius we need to draw 2 arcs on the either sides of this line segment. We are going to draw the perpendicular bisector of OP. So, we have to draw 2 arcs on the either sides of OP. Here in this case we have taken O as center of the O as center, right, and with the same radius, we need not to change the radius, with the same radius. Now, consider this P as center and try to draw 2 more arcs onto previous arcs. Okay, students. So, here first of all we have to consider the radius as a more than half. Okay, so in this way we consider the radius as more than half, and with that radius we have to draw two arcs on the either sides of the line segment by considering O as center. Then we have to change the center. Now the external point P is to be taken as center, and with this center we have to draw two more arcs onto the previous arcs. Okay, so here these two arcs intersected at two distinct points. Okay, so let us consider these two intersecting points as a x and y. Okay, now by using the scale or ruler, try to join the 2 points, okay. So this is the line which passes through x and y, is considered as a perpendicular bisector. If you measure the angle between OP and XY, it is 90 degrees. That's why it is a perpendicular, and it passes through the midpoint. Okay, so here the point of intersection is to be taken as a M. The point of intersection is to be taken as a M. Okay, now consider this point of intersection M as a center. Observe this, we have to take a M as center, and the radius is, you may consider MP, or if you measure MO, even it is same. Okay, so MP is same as a MO, so that we have to consider any length as a radius and try to draw the circle which passes through both O and P. Okay, it is the circle which passes through O and P, where O is the center of the given circle and P is the external point. Okay, after this we got two more points. What are the 2 points? Those are the points of intersection of two circles. Point of intersection of two circles. Okay, now let us name those points of intersection as a and here it is B, and we need to join PA, or the line passes through P and A, and another line passes through P and B. Another line passes through P and B. So if you notice, these are the two tangents. How can we conclude these are the tangents? So this is the line touches the circle. This is the given circle, no? So this given circle and this line has only one point of contact, so that PA is the required tangent. Similarly, PB is also another tangent. Is it clear? So these are the two tangents we can draw from external point P to given circle. Is it clear? So first of all, we need the radius of the circle. So radius of circle is given as 3 centimeters here. So here I will mark it as a 3 centimeters, and this is the position of external point. What is the external point here? The external point is 8 centimeters away, 8 centimeters away from center of the circle. Okay, so this is the radius 3 centimeters, and this is the position of the external point. Okay, so perpendicular bisector, construction of perpendicular bisector. How we construct this? Consider the radius as a more than half of OP. So clearly it is 8 centimeters. Half of 8 is how much? 4 centimeters. So we need to consider the radius as a more than 4 centimeters. More than 4. You may consider 4.5 or 5, whatever it may be. Okay. So the radius should be more than 4 centimeters. So by considering that as radius, that length as radius, we have to draw two arcs on the either sides of the line segment OP, and with the same radius, by taking P as center, we have to draw two more arcs, right? By joining those 2 points of intersections X and Y, we get a line which is the perpendicular bisector. So name the point of intersection, a given line segment, that is OP, and this is the perpendicular bisector. Consider the point of intersection as M. Now we have to consider this point M as a center. This point M is to be taken as center, and radius is either MP or MO. Clearly OM and MP is same as a 4 centimeters. Why? Because M is the midpoint of OP, isn't it? Why? Because this bisector XY is the bisector of OP. So here the distance is 4 centimeters and 4 centimeters. So consider this M as center and the radius as a 4 centimeters. Radius as 4 centimeters. By taking 4 centimeters as radius, if you try to draw the circle, it passes through both O and P. Okay, O and P. Now the two circles intersected at two distinct points. Let us name those 2 points of intersection as a and B. Okay, A and B. By joining PA and PB, we get the required pair of tangents from external point to circle. Okay student, I hope it is clear to you, and as it is given for 8 marks, you may expect the verification of the length of the line segment by using Pythagoras theorem. If you try to measure the length of the tangent, okay, so as the radius is 3 centimeters and here it is 8 centimeters, this 8 centimeters becomes the hypotenuse. Why? Because here it is a perpendicular, the radius and the tangent at point of contact both are perpendicular to each other, okay. So here angle at A is 90 degrees, then the side opposite to right angle is to be taken as hypotenuse. So 8 centimeters is the hypotenuse, and this OA is nothing but the radius. If you apply the Pythagoras theorem, you can get the length of AP by measuring it is around 7.4 or 7.5 approximately. It is to be taken as 7.5. Even if you apply Pythagoras theorem, we have to get 8 square minus 3 square. 8 square is 64, 64 minus 9. 64 minus 9, it is 55, right? So square root of 55, if you calculate square root of 55, it is approximately equals to 7.5. Okay students, so in this way we can verify, we can find the length of the tangent, and we can verify this with the help of Pythagoras theorem. Okay, so just practice this once again, and in textbook you have draw the circle of radius 5 centimeters, and the distance from center to external point is 13 centimeters. So by using the same concept, you can construct a pair of tangents. Okay, I hope it is very clear to you. Yeah, thank you for watching. Have a nice day.